Hello, my name is Bojan Mitov, the president of Mitov Software, and in this session I will show you how you can develop your own Visuino components with Delphi. Visuino is developed in Delphi, and it generates Arduino code. To be able to compile the code generated by Visuino to test the components, you will need to have the Arduino IDE installed. Next, you will need to install Visuino. To develop the components, you will need to have Delphi installed. Currently, Visuino is compiled with Delphi 10.2 Tokyo, so you will need to download and install at least the free starter version. Next, you will need to download and install the Visuino SDK. The SDK is available for download in the Visuino G+ community. The SDK is completely free and comes with some example components. Optionally, the full Visuino SDK source is available to everyone who is willing to sign NDA. I will quickly show you how to download and install the SDK. Go to the Visuino G+ community, go to Visuino Visual Arduino Developers, expand the About This Community bar, scroll down and find the link for downloading the Visuino Component Development SDK. Copy the link and paste it in your browser. Save the file. Open it and start the setup. Click Next, accept the terms of the licensing agreement. Here you can select the non-source code version or the version that requires registration key. To get the registration key, all you need to do is sign NDA. And I will send you the key. Click Next, 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 and install. The SDK is installed. Click Next and finish. Now we can start RadStudio. Each Visuino component consists of two parts. First is the Delphi visual component with its properties and pins and their attributes. The component will appear in the Visuino toolbar under the corresponding category. Each component can be part of one or more categories. When we drop the component, we can see and edit the component properties. All of this is described inside the Delphi component. The second part is the C++ implementation of the component functionality. The code generated by Visuino will use this C++ component implementation to compile and upload the code into Arduino. The Visuino component C++ code is typically located under Documents, Arduino, Libraries, Mitov folder. The standard Visuino components developed by me will be located here. All of these components are available as open source. If we want, we can open one of the files with RadStudio and look at the code. Here are examples of some of the components. There are many different types of components. One of the simplest types are the data processing components. There are also sensor components directly reading data from hardware, actuator components controlling motors, servos, relays, and others directly controlling the hardware. Their graphics displays components and lighting effects, controlling things like new pixels or dot star LEDs. The components can be completely implemented in our C++ code, or our C++ code can use existing Arduino libraries. The Visuino Components SDK comes with some example components. In Delphi, we can navigate to the RadStudio folder, open Webpacks, Meetup, Arduino, Examples, and then the 10.2 folder. Here we have a package group containing example components. We can open it. And look at the code of the example components. In the examples directory, there is also subdirectory code library. Here is the C++ code for the Delphi component. We'll start by looking at the included example code. The Visuino components are installed inside packages. We have runtime package and design time package, and the design time package requires the runtime package. Practically everything is located at the runtime package. The only thing the design time package does is register our component. This is a simple data processing component performing some function over the data. We will inherit from a common analog filter which introduces input and output pins and adds enabled property. So the component will have input and output open wire pins and enabled property. We will add three properties of our own for three parameters for our function, as example A, B, and C. We can specify default values for those coefficients, and we can specify design and value range for the coefficients. The design range will show the recommended range for values for the specific property, and value range can restrict the property to a minimum and maximum value which cannot be exceeded. So while this is the recommended range, we can go all the way to the full value range, but not any further. This is done with the help of attributes. We need to add few more attributes for the component. The first attribute is the name of the C++ include file that will contain the code of the component. This name has to match exactly the name of the C++ header file implementing the processing component. Next, we need to add attribute indicating the name of the C++ class that implements the component. Instance of this class will be created every time when we drop the component in Visuino. This name and the namespace will have to match the namespace and the class name in the C++ code. Next, we need to specify the name of the component as it will be shown inside Visuino. This name displayed on top of the component when we move the mouse over. Next, we should specify the name prefix that will be used when Visuino generates new name for the component. As example, if I drop this component, a text multi-merger will be used as prefix and one will be added automatically by Visuino. In our case, quadratic function will be used as prefix and then a number will be added by Visuino. Optionally, it is recommended to specify a toolbar category where the component will be listed. There are many categories to choose from, and once the component is added to them, it will be displayed in the corresponding category in the component toolbar. In this case, I have decided to add the component to the analog math filters toolbar category. We will also need to add some units into our uses clause. This is all that needs to be done to declare the component in Delphi. We will need to register it. There are a few different ways to register the components, but this is the way I would recommend you to follow. Declare register package function in the interface section of the file. In the implementation section, implement the function, called register components, and inside the array pass our component. Optionally, we can add resource with image for our file. If we use star.res, the star will be replaced by the name of the unit and the corresponding resource file will be added. We will look at the resource file a bit later when we create our own component. Our component is completely done. In the design time package, we will need to add our unit to the uses clause. In the interface section, add register procedure and implement the register procedure calling register package within our unit. This function here. That's all that needs to be done. Now we can build the package. Before we start implementing our C++ component, it is best to familiarize ourselves with the included C++ sources. Typically, two files are important for us to be familiar with. One is the meetup.h. It contains most of the base classes for variety of filters and other components, data types, serial communication, and many more. The second file is the openwire.h file. It contains the base objects, component classes, and pins. Your header file should have defines preventing it from being included multiple times. The second time you try to include the file, this define will skip the file content. It is always a good idea to declare your classes inside your own namespace. Typically, you would use your own name or the name of your company. Declare a class for your component. The namespace and the class should match what we have added as attribute into our Delphi declaration. Inherit from common component, in this case common filter. Optionally, type def the base class as inherited for easy use inside your code. Declare and initialize the properties of your component. Since we inherit from common filter, and common filter introduces the doReceive virtual method, we can override this method and, if enabled, perform our filtering function. If not enabled, we will simply pass the data that has been received in the doReceive to the output of the filter. The way it works is in the base class, in the constructor, we have set a callback for the input pin to be the doReceive method. When data is sent to the input pin, this data is going to be passed as parameter of the doReceive method, and we can process it inside our code. This is all that's needed to implement our component. Now we can start creating our own components. The first step is to create component package where we will put our components. We will create the package. We will make the package runtime only, as it will not be used inside the Delphi. We will set the version of the package to 250, which is the current Delphi package version for Delphi Tokyo 10.2. In the future, this number may change to the latest version of Delphi. We will have to set the Delphi search path for the package, so the compiler will be able to find the files from the SDK. And finally, we will add the required packages from the SDK, so the package will be able to use the units from there. In Delphi, select File, New, Package Delphi, save the package. As example, under this folder, give the package a name, in my case, my Visuino components. It is best if your package starts with your name or the name of your company to reduce the danger of the name of the package conflicting with the packages created by somebody else. And save the package. Right-click over the project file and select the options. Select all configurations. For the search path, paste the search path which I showed you in the PowerPoint presentation. This search path is for Delphi 10.2 Tokyo, and this number may change in the future. If necessary, you may need to change this number in future versions of Delphi. Click on the description. Select Runtime Only, and for lib suffix enter 250. Click OK. Now we need to add the required packages to the package. You can add them from here, or you can select View Source and paste them from the example package included in the Visuino SDK. I copied them from the example package as it saves a lot of time. The package is ready and we can start adding components to it. Next, we will add design time package. The design time package typically is used to register our components, and it can also add some advanced design time functionality. The steps are almost the same. We'll create Delphi package, make the package runtime only, set the package version to 250, set the Delphi search path the same as for the component package, add the required packages from the SDK. The only additional step is to add our components package to the required packages so the design time package can work with our components package. In Delphi, right-click on the project group and select Add New Project. From the Delphi projects, select package, save the package, and give it name. I prefer to add the suffix .design, keeping the same prefix as my components packages, and click Save. We can also save the project group. You can give it any name you want. Right-click on the package and select Options. Select all configurations for target. Set the search path exactly the same as we did for the component package. Switch to the description. Make the package runtime only. Set suffix of 250. Click OK. Right-click on the package and switch to view the source. Add the required packages and at the end add our components package, my Visuino components. The design time package is ready. To declare our Delphi component, we'll follow few typical steps. We'll inherit from one of the component base classes in the Visuino SDK. We'll add attributes to the component, add OpenWire pins and properties, add attributes to the pins and the properties. We'll register the component, create resource file containing the component icon in a semi-transparent PNG format, 32 by 32 pixels. We will use the resource file in the component, compile the packages and copy them into the component packages subdirectory of Visuino. Now we can go ahead and start writing our component. Right-click on the project and select Add New Unit. Save the unit. As example, calling it My Repeat Text Component. We'll write a simple component that receives some text and repeats it certain number of times. I will start by adding the units that we'll need for our component. We need to declare the component into the interface section. I will call it my repeat text. I will inherit from the Arduino common text filter. The component is declared. Now we need to add some properties. We'll just add a count property. I will add field for the property. And I will make it cardinal, which is unsigned integer in Delphi. Next, we need to declare property. The properties will be in the published section, so they will be available at design time. I will set default value of 3. Optionally, I can specify a value range for the count. As example, between 0 and 100. This way, we will be able to set only values between 0 and 100 for the repetition count. Next, I will specify the toolbar category for the component. I will use the basic text toolbar category, which is defined in MITUF categories SignalLab Basic. We will give the component a friendly display name. As example, my repeat text. We will specify what will be the prefix when we create new component by using createName attribute. To generate the Arduino code, we will need to specify the include file that will be added to the Arduino sketch. I have decided to call the header file my components repeat text. Finally, we need to specify the namespace and the name of the C++ class implementing the functionality of the component. We'll use the Arduino component attribute and we'll pass the namespace. I have decided to call my namespace my components. Use your name or the name of your company as namespace, or pick another fairly unique namespace. And the class will be called repeat text. Now I will add the function to register the component. In the declaration section, declare the function. Copy and paste it in the implementation section. At the begin end. Add register components, open bracket, open square bracket, and paste the component, then close the brackets. The code for the component is ready. The component, however, will not have user-friendly icon. To add icon, we can add a resource file. The resource file can have the same name as our component unit, so we can use the star for the resource file name. The simplest way to create resource file is to copy one of the existing resource files and rename it, or open the project folder, filter for resource files, copy the package resource file and rename it to match the unit name of your component, and close the window. We can use any resource editor to edit the file, and since I have Visual Studio installed in a virtual machine, I will show you how you can use it to edit the resource file and add the component icon. In Visual Studio, open the resource file, delete the RC data and the version, right-click over the file and select Add Resource. From the dialog, select Import, navigate to the folder with your icon, select the icon and click Open. The icon should be a semi-transparent PNG file 32 by 32 pixels. Right-click over the newly added image and select Properties. For the ID of the resource, click Open Quotation in Delphi, highlight the name of the component anywhere in the code, and click Ctrl-K, Ctrl-F. This will change the text to uppercase. Highlight and copy it so you can paste in Visual Studio. Then click Ctrl-Z to undo the change. You will need to click Ctrl-Z a couple of times to return to original case. And paste the uppercase name of our component. Close quotation. Save the resource file and you're done. Now we can add code to register our component in the design time package. Activate the design time package, add unit to it. Save the unit. I have decided to name my Visuino components that register, since we can use this unit to register multiple components across multiple units at once. In the interface section, we need to add register procedure and write body with begin end. In the implementation section, add uses clause and add our component unit there. by copy and paste. Paste the unit in the register procedure and call the register package function inside the unit. The code is ready and we can register our component. To install the compiled packages in Visuino, we need to copy them into the component packages subdirectory of Visuino. We can do that by manually copying the files, or we can configure Delphi to put the packages there upon compilation automatically. For this, we will need to set the package output directory. Navigate to Visuino, Component Packages, and copy the path. Open the project options. In the Delphi compiler, set the package output directory to the directory we just copied. Repeat the same procedure for the design time package. Right-click over the project group and select Build All. The packages have compiled and have been deployed to the Visuino directory. If we start Visuino now, you will see that our component will appear in the text category and we can add it. I will create a quick test project for it. I will add a value text component, set the value to hello, add set value state element, and set the value to world. Close the elements editor. Connect the output of the text value component to our test component. Add post generator. Connect the post generator to the value element. Save the project. We can generate the Arduino code, however, to compile, we need to implement the C++ class for the component. To implement the C++ code for the component, we will follow few typical steps. Declare component class inheriting from one of the base classes in the Visuino SDK. Add fields matching the properties declared in Delphi. Add OpenWire pins matching the ones in the Delphi component. And finally, implement the processing function. To implement the C++ code, we need to create a new header file. I will select File, New, Other Files, and pick Text File. From the list, I will select C++ header file.h, and I will save the file. I will go to Documents, Arduino, Libraries, and I will create my own folder. Make sure to create fairly unique name, since there is a danger for this name to conflict with the names of other Arduino libraries. I will name my file My Component Repeat Text, exactly the same way as we did here. First, I will add if-defs checking to see if the header file already has been included. Next, we'll include the header file with the Visuino base classes. Now we need to create our own namespace. Declare our class and we'll inherit from the OpenWire component class. Since we will not access the base class, we can skip the declaration of the inherited. We could have inherited from some of the base filters. However, if you inherit directly from OpenWire component, you will save some memory in the generated Arduino code, which is always a good idea. Now we need to add input and output pins. The basic component doesn't have any pins, so we will add them ourselves. Next, I will add the count property, and I will initialize it to the default value. In order to do processing, we need to set callback for our input pin. We will do that in the constructor. Now we will add the callback implementation. In this implementation, all we need to do is loop from 0 to count. And for each iteration, send the data to the output pin. The component is ready. Now we can go back to our Visuino test project, click on this button to generate the Arduino code and open the Arduino IDE. Then click on this button to compile and upload the code. The code is uploaded, and if we click on the serial monitor, we will see that the words will be repeated 3 times every time. Our component is working. We can also set the count, and we can set it from 0 to 100, exactly as specified. Congratulations, you have just created your first Visuino component. My name again is Bojan Mitov, the president of Mitov Software. Mitov Software offers variety of Delphi and C++ Builder products, including VideoLab, a video processing library, AudioLab, audio processing library, SignalLab, a digital signal processing library, VisionLab, computer vision library, PlotLab, data visualization library, InstrumentLab, a visual instrumentation library, Intelligence Lab, artificial intelligence library, Logic Lab, Boolean logic library, Animation Lab, Universal Animation Library, Communication Lab, Serial and TCP/IP Communication Library. That also includes MQTT, Control Lab, Industrial Control Library, Visual Live Binding, Universal Visual Live Binding Library, the free Mitov Runtime Delphi Library. In addition to the libraries, Mitov Software also provides OpenWire Studio, a graphical development environment for Windows, Visuino, a graphical development environment for Arduino type boards and microcontrollers, Visuino Pro, a graphical development environment for Arduino-based industrial PLC controllers. Mitov Software also maintains some open source Delphi libraries, including the OpenWire library and iGDI Plus, a Delphi-friendly GDI Plus library. The majority of the components included in the libraries are already ported to support cross-platform development in Windows, Mac, Linux, iOS, and Android. Mitov Software is working actively to port practically all of the components to cross-platform development. This concludes this session. Thank you for listening, and now it's time for questions and answers.